Lesson 9.5, Resistors in Series and Parallel. There's two basic ways to wire circuits. The first is in series, and that's when we have more than one device on one circuit. As you can see in the diagram, we have 3 resistors all in a row. The same current goes through all 3 devices because it's the only place the current can go. It has no choices. A break in a device, like one of the resistors broke, there would be a hole in the circuit and no current would flow. So that's like Christmas lights. One Christmas light bulb goes out or gets lost and all the lights go out. In series wiring, it forms one loop. And the resistors are going to divide the voltage between them. So if they're exactly the same, if we had a 30-volt battery, each of the resistors would use 10 volts if they're all the same. The voltage gets divided amongst the resistors, so our total voltage would be V1 plus V2 plus V3. But V equals IR, so I could replace the V's with IR's. But since the current's the same, we could factor out the current and say it's V equals IR, where R is the series equivalent resistance. So the resistance in series is just adding together the individual resistors. So let's say a 5.17 kilo ohm resistor and a 10.09 kilo ohm resistor are connected in series. What is the equivalent resistance? Well, it's connected in series, so we just have one path for our current to go through. So it's in series. So our resistance in series is just adding up the individual resistances. Which will make it 15.26 kilo ohms. Bathroom vanity lights are sometimes wired in series, not often, but sometimes. Let's say the voltage is 120 volts, it's your standard wall outlet, and you put in 3 bulbs, each with 8 ohms, and you have one bulb that didn't match and it's 12 ohms resistance. What is the current, voltage of each bulb, and the total power used? We have 3 questions here. Well, if we're in series, our resistance for the series is just adding up the individual resistances. So we have 3 of the 8s and 1 of a 12 ohm. So that gives us 36 ohms of resistance. So that's for the entire circuit. So with the whole circuit, I can do Ohm's law, V equals IR. We have 120 volts, and our resistance is 36 ohms total. So divide, and your current is 3.33 amps, or 3 1/3 amps. All right, so that's the first question. Now we want the voltage of each bulb. Well, we have 2 types of bulb. If I go with the 8 ohm bulb, I can do V equals IR, but now I'll just talk about that bulb. The current is 3.33. The entire circuit gets that current, and our resistance is 8 ohms. So multiply those and we get 26.7 volts. For the 12 ohm bulb, we can do the same thing. V equals IR. We're looking for the V. The I, the current through everything in this circuit, is the 3.33 amps. But it's 12 ohms. So that gives us 40 volts. Notice if I go 3 times the 26.7 plus 40, 3 because there's 3 8-ohm bulbs, we end up with a total of 120 volts. Total power, okay, for total power, we can do the whole circuit again and just do whatever we know. Could do P equals IV. Our current's 3.33 amps. Our volts is 120. So if we multiply those, we end up with 400 watts. Turns out if we had found the power used by each individual bulb, by maybe using P equals IV, I mean we know the V's, or I squared R, we would have ended up with things that we could add up together to make the 400 watts. The other basic type of circuit is parallel wiring. It's the same voltage across several devices. So you can see here in our picture, both little loops are connected to the ends of the batteries. So our current could go through the first loop or through the second loop. Since they're connected to the two ends of the batteries, they are connected to the same potential, so the same voltage, because the battery is what makes the voltage. This is typical household wiring. And if you break one device, it doesn't matter because you still have a loop through the other device and everything else still works. But in this case, the current gets split up. Both the top and bottom picture here are exactly the same thing. We just move the edge of the battery to there. But the current comes out of the battery and then splits. It can go through the middle resistor or through the top resistor. And then it comes back around and combines at the other node into a single current coming back to the battery. So this current got split between the two resistors. More will go where there's least resistance. Each branch will draw the current as if the other wasn't there. And each branch draws less current than the power supply gives. I mean, if we have the battery and the current goes and it splits, then the total coming out of the battery has to be more than what goes into either branch. All right, so if our resistance is V over I, overall, there's a large current, so a small R. Those are inversely proportional. So in total, there's a smaller resistance than there is in either branch. So since the current gets divided in parallel our total current equals the sum of the currents of the two branches. But I equals V over R, so I can replace the I with V over R. They have the same volts though, so we could factor out the V. And we have 1 over R plus 1 over R. We would say that's 1 over R parallel, the total resistance in parallel. So our total resistance in parallel is found by 1 over Rp equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on. Now beware, these are fractions. To add fractions, you need a common denominator. You just don't add the numbers in the denominator. you'll need a common denominator, or just use a calculator. Let's say a 1004 ohm resistor and a 101 ohm resistor connected in parallel would be the equivalent resistance. Well, 1 over R in parallel is 1 over R1 plus 1 over R2. So that'd be 1 over 1004 ohms plus 1 over 101 ohms. Now, use your calculator to do this, probably. And you get that per ohm. So I have 1 over Rp equals that number. I want Rp, not 1 over Rp. So if I follow the golden rule of algebra, say I do the same thing to both sides and reciprocal both sides, that would give me Rp equals 1 over 0.010897. The ohms on top now, which is 91.8 ohms. Notice that is slightly less than either of the resistors. The total, when you connect in parallel, is less resistance than the individual resistors. Now, if we connected this to a 3-volt battery, how much total current would the battery supply? Well, I have some total resistance, so we are doing the whole circuit now. I can do V equals IR. So if it's 3 volts and our resistance is 91.8, divide, and we end up with 0.0327 amps, otherwise known as 32.7 milliamps. How much current, though, would then go through each resistor? Well, I could take each one separately. Let's say if I go through the 1004 ohm resistor, I could still do V equals IR. In parallel, they have the same volts. They're connected to the same end of the battery. And we're looking for the current. The resistance is 1004 ohms, which gives me 0.0030 amps, or 3 milliamps. When we do the 101 ohm, do the same thing. It also has the 3 volts because we are in parallel. They have the same volts in parallel. Divide, and we get 0.0297 amps, or 29.7 milliamps. When we add those together, we get a grand total of 0.0327 amps, which is the same as 32.7 milliamps that we had before. So our individual resistors had 3 milliamps in the bigger one and 29.7 milliamps in the smaller one. So there's more current in the smaller resistor when they're in parallel. When you're in parallel, the current follows the path of least resistance. More current, smaller resistor. That's in parallel. Remember, if we're in series, all the resistors have the same current.